So in this video, I want to look at the law of sines and the obtuse angle quote-unquote glitch, the obtuse angle glitch for the law of sines. So let's say I'm going about my day, and I have this triangle here where capital A is given to be 40.55 degrees, little a is 7, little b is 5, little c is 10, and we were to use the law of sines to find big C. So if I were doing that, I'd say that the sine of big C over little c equals the sine of big A over little a. So c is unknown, so we're going to keep that sine of c over little c is 10. Sine of A is 40.55. I'll just write that in there, and little a is 7. So I can cross multiply and bring the 7 up top there on the right, so I get the sine of big C equals 10 times the sine of 40.55 over 7. Now, I'm going to try to find big C. So traditionally, to find big C, you get rid of the sign on the right and you take the sine inverse. So let's try this. This is going to be our first attempt. And we're going to show how it actually fails. First attempt at solving for big C. So kind of typically what we do, we drop the sign on the left and we take the sine inverse of the right-hand side. The right-hand side being 10 sine of 40.55 degrees over 7. Now make sure this is in degrees mode, first of all, in your calculator. So if you plug this in your calculator, you should get that C is approximately, so sine inverse 10 times sine of 40.55 divided by 7. You should get it's about 66.8 if you plug that exact sequence of buttons in your calculator. But there's a problem. If you think about this angle here, C, right, this angle C is definitely not 66.8 degrees, right? That angle is an obtuse angle. Obtuse means it's greater than 90 degrees. So that has to be wrong, right? There has to be something wrong with that, because we're definitely bigger than 90 degrees at C. So something has gone wrong. So my first question is, what has gone wrong? Remember when we're taking the sine inverse, let's recall. Recall the following. When I'm saying that the sine of theta equals y, this is equivalent to saying theta is the sine inverse of y. But you can only do this when your angle theta is between negative pi over 2 and positive pi over 2. In other words, theta has to be between negative 90 degrees and positive 90 degrees. So the problem is here, this angle C is not between negative 90 degrees and positive 90 degrees, right? This angle C here is more than 90 degrees, so you actually cannot directly use the sine inverse. So here, we cannot use sine inverse to calculate C, since C is not between negative 90 and 90 degrees. So rather, if we look at C, C is bigger than 90, right? So rather, C is greater than 90 degrees. So I guess the question is, what do we do when we have an obtuse angle, an angle bigger than 90? Well, that's the real question. So here's an important fact. The sine of 180 minus C is the same as the sine of C. Why is that true? Let's actually prove this. Let's do a little proof of this fact. If I use the difference formula for sine, I get the sine of 180 times the cosine of C minus the sine of c times the cosine of 180. That's left-hand side of my equation. Sine of 180 is 0. Cosine of c is cosine of c. I have minus sine of c. Cosine of 180, that's actually -1. So I end up with 0. And negative sine c times -1, that's going to be positive sine c. So I get sine of c here, which is the right-hand side of my equation. So that fact is actually useful. Sine of 180 minus c is sine of c. So if I go back here to this step right here, let's rewrite this. This is going to be my second attempt. Attempt number 2. Remember, I had the sine of c, what was it, equals 10 sine of 40.55 over 7. So since c is bigger than 90, I cannot just use the sine inverse, cannot use the sine inverse here. So what I'm going to do, I'm going to replace sine of c with sine of 180 minus c. So why can I replace c with the sine of 180 minus c? Well, because they're equal, right? I got sine of 180 minus c is 10 times the sine of 40.55 degrees over 7. Now, if c is bigger than 90, then 180 minus c, that would have to be less than 90. So 180 minus c is less than 90, then I can use the inverse sine function. So I can say 180 minus c equals the sine inverse of 10 sine of 40.55 all over 7. So to solve this, well, I'm going to take out my calculator like before, and I'm going to press the sine inverse of 10 times the sine of 40.55 over 7. Remember last time we calculated that to get 66.8. And that was 66.8, but now we have to solve for c, so I'm going to pull the c to the right, and I'm going to subtract 66.8 from both sides. I'm going to end up with 180 minus 66.8. And I get that c is actually about 111.8 degrees. So that's actually our correct answer, and you can see, yeah, that makes more sense because this is an obtuse angle, so this is 111.8 degrees. So if you're going to use the law of sines to find an obtuse angle, an angle greater than 90 degrees, you're going to have to perform this trick where you basically replace the sine of c with the sine of 180 minus c. So if you want to avoid this kind of trick, this kind of complication, then you can just use the law of cosines. In the law of cosines, you don't have to ever worry about obtuse angles, because remember, for cosine inverse, your angle can be from 0 to 180, from 0 to pi, right? 0 to 180. So law of cosines avoids this complication entirely, so you can always go to that if you don't want to